All right, this is the 7th grade math textbook. We're looking at some practice problems from section 2 of chapter 3. Let's see what we have. We're looking at substitution here. So the problem would ask something like find the value of 3x minus 1 when x equals 1 or when x equals 4 over 5 is what we're looking at here. So really simply, we're taking whatever that variable is, x, and we are literally plugging in whatever number they're asking us to and solving. So if we were going to do the first one, the one boxed in green, we would say 3, and instead of x, we're putting in a 1 minus 1 here. And just like the order of operations, we always start with parentheses first. We don't have any expressions in parentheses. We only have a single digit in parentheses, which doesn't apply here. An exponent, we don't have multiplication and division. We start from left or right. The first part we would do would be this 3 times 1. Anytime two numbers are smushed together like that, specifically with parentheses around a single digit, that means multiplication. So 3 times 1 equals 3. I'm going to rewrite the rest of my problem that I didn't use just so that I can keep everything in order. And then after multiplication and division, which there isn't any more of, we would move to addition and subtraction. The only addition and subtraction problem that we currently have is 3 minus 1. 3 minus 1 is 2. And that is the end of that one. Let's look at the second one here. We're going to be substituting, instead of a 1, we would substitute in a 4 over 5. This is going to be the red boxed problem here. So again, I rewrite my problem, putting in my new substituted x as such, and again follow my order of operations. So we are starting with parentheses. No, there isn't an expression inside of parentheses. There is next exponents. No exponents, multiplication, division. Yes, same thing as last time. We're going to solve this here. We can solve that by putting the 3 as our expression in the numerator. All right, so 3 times 4 is 12. 12 over 5. And then we can go ahead and write the rest of the problem down. This is the only part that we're missing. And we're going to subtract 1 from this. All right, so if we were going to go ahead and subtract this, I'm going to write it up here on the top so that we can see the difference here. 12 fifths is farther than a whole, which is what we're trying to subtract here. So if we break this down, a whole we know is going to be the same numerator over the same number denominator. In this instance, 5. If we take 5 of those 5 pieces away, we're taking away 1 whole. What you would be left with here would be 7 of those 5 pieces. We could solve that way and realize that we're trying to take away this whole here, being left with 7 fifths. Or another way that we could do that would be to go ahead and change 12 over 5 into a mixed number and then subtract. Pretty similar to what we just did, but realizing that the number of wholes we can take from 12 pieces, if 5 is our denominator, 5 are the number of pieces that fit in each pie, in each pizza, in each candy bar, each fraction tile, then we know that we can pull 2 sets of 5 out. That would be 10 fifths that we just pulled out, and we are left with 2 fifths. and we are subtracting one of those, we can subtract our whole numbers first. 2 minus 1 is 1, and we are left with that partial piece of 2/5. If we were to change this, could also be an answer. If we were to change this back into an improper fraction, we would say 5 times 1 is 5. That would be your whole 5 over 5. Add additional pieces in. 5 over 5 plus 2 over 5 is 7 over 5. So we still end up with that same answer of 7 over 5.